Hey y'all, welcome back. Tonight we are reviewing for our Unit 6 test, which is all about quadratic functions. And we're looking at problems that you might expect to see on either the CLEP College Algebra or the TSI College Entrance exam. All of these have to do with quadratic functions, and they've been sort of hand-picked out of the released practice tests from College Board. So without further ado, let's go ahead and get into the problems. Number 1 says, which of the following expressions is equivalent to 7 minus 2x quantity squared? So whenever you're squaring something, that means that you're multiplying it by itself. So we should have 7 minus 2x times 7 minus 2x. Now to multiply by binomials, what you're going to do is you're going to distribute or use the distributive property on the first binomial. So what I mean by that is you're going to take each term in that first binomial and multiply it by each term in the second binomial. So we'll multiply the 7 by 7 and negative 2x and do the same thing with negative 2x. So here 7 times 7 is 49. 2x times 7 is going to be 14x, and since that 2x is negative, it'll be minus 14x. Distributing the negative 2x, we have negative 2x times 7, which is going to give us another negative 14x. And then finally, 2x times 2x will be 4x. Both of these terms are negative, which is why when we multiply them, we get a positive 4x. 4x squared, sorry about that. So now we need to combine our like terms. We've got negative 14x minus 14x. Those will combine to give us negative 28x. And here we are going to have our final answer, 49 minus 28x plus 4x squared. And if we're looking at our answer choices over here, make sure that we can actually find it. It looks like it's going to be choice E. So yeah, that's going to be our answer here. For number 2, it says, which of the following are solutions of this equation? What we want to do here is multiply these together, get this equation into standard form, and then solve it like a quadratic, which means we're either going to factor or use quadratic formula. Now, there's a shortcut to this problem, which I'm not really going to go through, but I'll mention it, is that you could just take these answer choices and plug them into x and see which one ends up equaling negative 15. It shouldn't take long since these are all pretty different, and so if you can find one of the solutions, odds are you're going to find the answer. But I'm going to work it out the conventional way here, which is to first get this thing into standard form. We want to multiply 6x by x and then 6x by 2. We'll do that first. 6x times x is going to be 6x squared. 6x times 2 is going to be 12x. So we get 6x squared plus 12x. And then we'll distribute the second term in that first binomial, the negative 7 times x, and then negative 7 times 2 will give me negative 7x minus 14. And that should equal negative 15. Now I'm going to combine my like terms, and I'm going to add 15 to both sides. So combining these two like terms, 12x minus 7x is going to give me 5x. So I have 6x squared plus 5x minus 14 equals negative 15. Now I want to make this equal 0, so I'm going to add 15 to both sides. I get 6x squared plus 5x. Negative 14 plus 15 is going to be positive 1, and this should equal 0. So now I need to factor this, and I'm going to use the same technique that I used in class, the Xbox method. Okay, so if you're not familiar with that, if you're watching this and you haven't seen, go back to some of my older videos from earlier in this unit, and you'll see me go into a little bit more detail about how this works. So I'm going to run through this pretty quickly since we've done it so many times, though. So the Xbox method is one where we're going to basically, sometimes it's known as the reverse box method for multiplying binomials. I'm going to create this 2x2 box here, and I'm going to write the first term, or that leading term, this 6x squared, in that first box. So I'm going to write 6x squared here. and I'm going to include the constant term, which in this case is the plus 1, down here. Okay, so I'll put 1 there. And then what we need to do is figure out how to correctly split up this middle term. You know, there's infinitely many ways we can add two terms and make it equal 5x, but only one way that's going to work for this factoring. And so what we need to do is we need to come up with two numbers that multiply to give me 6, but add up to 5. The 6 being 6 times 1, and then the 5 being just the middle term here. So two numbers that multiply to give me 6 and add up to 5 would be 3 and 2. And so I'm going to take this 3 and 2 and slap on an X and complete this little box here. It doesn't matter which one goes where. The factoring will work out either way. And so now that I've got the box filled out, I'm going to pull out the greatest common factor of each column and each row, and that's how I'm going to get the factors for this polynomial. So the factor, the GCF of this first column is going to be 3x. The GCF of the second column is going to be, well, I guess it's just 1, so plus 1. The GCF of this first row would be 2x. And the GCF of the second row, will be 1. So we've got our two factors here, 3x plus 1 and 2x plus 1. So I'll write those both in their own individual sets of parentheses. Set it equal to 0, and now I'm ready to go to finish this one off. So basically, to complete this, I'm going to set each one of these equal to 0 and solve them independently. 3x plus 1 equals 0, and 2x plus 1 equals 0. These are both two-step linear equations, so I'm not even going to show every step here. I'll just talk through it, because it's really just two steps for each one of these. But for this first one, we would subtract 1, which would give us negative 1 here, and then divide by 3, so our answer would be negative 1/3. For the second one, we could subtract 1 and then divide by 2, and that's going to give us negative 1/2. So these are the two solutions to the equation, and if we look at our answer choice, we can find those in letter B. Not 8. Let's try that again. B. Okay, there's number 2. Number 3. Which of the following are solutions to this equation? So another problem very similar to this one. I'm seeing a bunch of square roots in these solutions though, so that's kind of an indication that maybe we should use the quadratic formula on this one versus factoring that we did up here. We could have used quadratic formula for this one once we get it equal to 0 at this stage, but I just chose to do factoring just to kind of show you this. But this would be a good example of one where maybe we want to use quadratic formula. So just as a reminder, I'll put the quadratic formula up here. You should know it by this point, but if not, that's okay. Negative b plus or minus the square root, where's that plus or minus? There we go. Plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, that's going to be the formula we're going to use, but we can't use this yet. What we need to do first is manipulate this equation so that it equals 0. Get it into standard form, essentially. So to do that, I want to first subtract 8 on both sides, and that'll give me 4x squared plus 6x minus 8 equals 2x. Or sorry, negative 2x. And then if I add 2x to both sides, I can combine that with this, and that's going to give me 4x squared plus 8x minus 8. Now at this stage, usually what I would recommend is to see if there's anything we can't divide on both sides. I didn't really do that over here, but that was because we had a 1 here and that was prime, so I didn't really think to try to divide anything because nothing would have actually worked. In this case, though, all of these are divisible by 4. So if I divide each one of these terms by 4, I'll get x squared plus 2x minus 2. And so now I'm going to use the quadratic formula. I didn't really have to do this step. You could have used 4, 8, and -8 as your A, B, and C here. So if this step kind of confuses you a little bit, it's not necessary, but I like to keep these numbers as small as possible if we can. So that's why I divided everything by 4. All right, so we've got our A, B, and C, and now we're ready to use this quadratic formula. Okay, so here we go. B is 2, so I'll make that replacement. A is 1, and C is -2. And maybe just to make this a little bit easier to read, I'll put that in parentheses here. There we go. All right, and A is 1. So we don't really need this because multiplying by 1 doesn't do anything, but that's fine. Okay, so here's what our answers look like. Now I would use a calculator to do this computation here. You do have the ability to use a calculator, not only on this test, but on the CLEP test itself. So just become familiar with it. We got 4 plus 8 is 12. And 12, and then 2 times 1 is 2. All right, so there's one thing we could do here, and that is we could rewrite this root 12 as 4 times 3, right? So 12 is 4 times 3. So maybe I'll rewrite this a little bit. Okay, this is 4 times 3. And what we know is that the square root of 4 is 2. So what we can do here is just put a 2 over here. Take that out. And now we have -2 plus or minus 2 root 3 over 2. And if I simplify this by dividing everything by 2, I'm going to get my final answer here. So -2 divided by 2 is just going to be -1. And then 2 divided by 2, again, is just 1. So we get -1 plus or minus root 3. And we can see that those two solutions are present in, let's see, which one? In letter D here. Now, in this question, we could have approached this with that alternate strategy that I talked about in number 2. And that is to just plug in the answer choices. So like going back to number 2 here, we could have just like plugged in a third into x here and here. You know, throw this in your calculator, see if it equals -15. If it doesn't, move on to the next one and so forth. We could do that down here as well. We could have tested 8 in this equation. Actually, if we test 8 in this equation and it's not going to work, which it won't because it's not a solution, we could actually eliminate both choices A and B at the same time, which would be nice. And then you could try, this, and you'll notice that one's not going to work if you plug that in. Eventually, once you try this one, you'll get one that actually does work. So don't be afraid to type these x values into the calculator to find your solution. Number 4 says, what are all the values for B for which this equation has either 1 or 2 solutions? Okay, so for a little bit more explanation on this one, please go back to the notes video. I go into a lot more detail as far as like how to determine 1 or 2 real solutions. But in this case, in this particular case, since we want 1 or 2 real solutions, that means that the discriminant, which is b squared minus 4ac, must be either 0 in order for there to be 1 real solution, or positive in order for there to be 2 real solutions. Now the discriminant, if I can spell, discriminant, okay, that looks better, is b squared minus 4ac. And if we want it to be 0 or positive, that means the same thing as saying greater than or equal to 0. Now for this problem, our A is 5 and our C is 5, and we're trying to find B. So I'll just plug these numbers in. A is 5, C is 5. And so let's see, what would this be? 20 times 5 is 100. So this one works out really nicely because we get that perfect square. B squared minus 100 is greater than or equal to 0. If we add 100 to both sides, we get b squared. It must be more than or equal to 100. Now, 10 squared is 100, right? So if this was 10, these would be equal, which would be a solution. And that's kind of the dead giveaway here, is that it's going to be D. But really, since this is b squared, this b could be negative, right? It could be something like negative 10, and negative 10 squared is 100 as well. The solutions that are greater, that would make this greater than 100, would be any number bigger than 10. So like, for example, if you plugged in 11 here, 11 squared would be 121, which would be greater than 100. So if we're trying to visualize these solutions, okay, we've got 10 and we've got negative 10 as sort of our benchmark points here, our critical values, if you will. And all the points, all the numbers that are bigger than or equal to 10 would be solutions. And the same thing goes for those negative values. Any number that's basically further away than 10 from 0 is going to be a solution. So here's what it looks like visually. All these numbers to the right of 10 and to the left of negative 10 will be solutions. And so the way we can write that is b is either going to be less than or equal to negative 10, or, let's throw in an or there, or b is bigger than or equal to 10. And so this answer choice we can see is letter D. Okay, again, if you want some more information about the discriminant and how it comes into play with this problem, go back to the notes video, and you can even go back to the homework video and go over a couple more examples. I believe this was 6-2. No, you know what it was? It was 6-1 because it was problem 4. So, yeah, go back to notes 6-1, homework 6-1. We also go over, we went over polynomial inequalities or quadratic inequalities in our last unit. If you check out, I believe it was notes 5-3, you might be able to find some more information. Okay, number 5. It says a rock is thrown straight up into the air from a height of 2 feet. The height of the rock above the ground in feet, t seconds after it is thrown, is given by negative 16t squared plus 56t plus 2. For how many seconds will the height of the rock be at least 26 feet above the ground? So to visualize what's happening in this problem, I'm going to draw a picture of this. Okay, just a rough sketch here where this is the height, here's the time. And then we toss it up at 2 feet. This must be a very short person here. Okay, nothing against short people or anything, but in order to throw this up from a height of 2 feet, you cannot be that far off the ground. So I'm guessing this is probably a child or something throwing this. Or just a really short person, who knows. Okay, so we're going to throw it up, and it's going to come back down. And the question is asking, how long is the height of the rock above, say, 26 feet off the ground? So if this is 2 feet, 26 is going to be somewhere over here. And what we're interested in is these 2 times when the rock hits this 26 feet mark. So like roughly here and here, right? And these 2 correspond to 2 times. In other words, the rock is going to hit this height at 2 different times. I know I'm not really making a very good straight line here, but hopefully you kind of get the point. Okay, so we got 2 times here. I'll call this time 1 and time 2. Good, those are really ugly T's, but hopefully they're good enough. Okay, so what we're interested in here is how much time is it above that 26 mark? Like, what's the time that's elapsing from here to here? So if we can find these 2 times, then as long as we just subtract them, we'll have our total time. So that's going to be how we get our answer here. Our answer here is going to be that second time minus the first time. So that time that it's 26 off the feet coming back down versus going up. Okay, so this is just kind of strategically how we're going to approach the problem. But now let's get into the algebra here. So we want to know at what time is the rock 26 feet off the ground. So we'll set that height equation to be equal to 26. And we're going to solve this. I'm going to start by subtracting 26 from both sides. And 2 minus 26 is going to be negative 24. And now we're going to set this, so, well, I guess we already did. We set it equal to 0, and now we have a choice. We can either try to solve this by factoring or quadratic formula. I think I'll go the factoring route. To make this a little easier, though, what I'm going to do is divide both sides by, let's see, is 56 divisible by 16? No, but it is divisible by 8. So yeah, what we can do is divide both sides by negative 8 to make the equation easier or simpler. Or maybe I'll just say to simplify the equation. Okay. Here we go. All right, so negative 16 divided by negative 8 is going to be 2. 56 divided by negative 8 is going to be negative 7. 24 divided by 8 will be 3. So this is my new equation, and this can be factored as 2t minus 1 times t minus 3. If you want to verify that or work it out kind of the long way, go back to problem number 2 where I talk through this Xbox method on how you can do that. This one you really don't need to do that because both 2 and 3 are prime, so there's only really so many combinations that these numbers could take on. But you know, I would advise if you can't go straight from here to the factors to try that Xbox method, and you should get these same 2 factors. So if I set each one of these equal to 0, like 2t minus 1 and t minus 3, I'm going to get the 2 times at which this rock hits 26 feet. So the first time is going to be when 2t minus 1 equals 0. If I add 1 and divide by 2, I'm going to get 1/2. And I'll write it as 0.05 because we're going to have to subtract these eventually anyway. On this one, if I add 3 to both sides, I get t equals 3. So these are going to be our 2 times here. And I'll just actually call them time 1 and time 2. I'm just assigning those numbers so you can keep track of when that happened. Here, I'll actually do that over here. Okay, so this is going to be 0.5, and this one's at 3. So the question is, how much time has elapsed in between those? And to find that, we need to subtract those 2 numbers. So this is going to equal 3 minus 0.5, which is 2.5 seconds. And we see that is going to be choice C. Okay, there's number 5. Let's do number 6. Finish off this second sheet here. In the figure shown, the graph of the function g is a transformation of the function f. Okay, notice here that the width of these 2 parabolas is the same. Like if I go over 2, I go down 2. On this parabola, and if I look at the other parabola, if I go like starting from the vertex over 2 down 2, I hit the parabola. So the width on both of these are the same, and that means that this a value should be the same on both of these. Now, all of these answer choices have that negative 1/2, so it doesn't really help us to even identify that, but I did want to point that out, that if these had different widths, then this a value would have to be different. But this is one set up so that they're the same. And really, all you need to keep track of is how do we get from f to g. And in this case, we're going to the right 2, and then up 3. Okay, now this is another case where I'm going to encourage you to go back to the notes where we went over a problem similar to this, and we went into a lot more detail about how to decide how to write the equation, based on the movement that's happening here. Right 2 up 3 is going to look like this. If I go up 3, then I should have a plus 3 at the end of my function, which I see here and here. I guess I see it down here too. So these 2 would be wrong. Right? These are showing a shift down 3 units. The other thing is the shift to the right, and this one where it gets a little confusing because we are shifting it to the right 2 units, but because of the way that this functions are written, if you want to shift to the right 2 units, you're actually going to have a -2 in this parentheses. Okay, so this would be correct, this would be correct, this would not be correct. This would be actually a shift to the left here. So the only equation that has everything like in the right place here is going to be B. Okay, and that's because we had 2 shifts here. We had a shift right 3 units. No. Jeez. 2 units and a shift up 3 units. And that's it for number 6. Number 7 says, for each graph, state whether the discriminant equals 0, is greater than 0, or is less than 0. So this expression, this b squared minus 4ac, that is known as the discriminant. And the discriminant is what determines how many solutions your quadratic will have. Okay, if it's equal to 0, then you're just going to get 1 solution. Okay, 1 real solution, I should say. And the way that's going to be represented on the graph is as an x-intercept. So as long as there's 1 x-intercept, you can say that the discriminant equals 0. If the discriminant is positive, then you'll have 2 real solutions, so you'll have 2 x-intercepts. Maybe I'll put it over here. And if the discriminant is negative, we'll have no real solutions. Both the solutions will be imaginary, and so we will have 0 x-intercepts. So understanding the relationship between the discriminant and the number of x-intercepts is what's going to help you answer this question. So the first one you can see has 2 x-intercepts. All right, we see one right here and right here. So 2 x-intercepts. So in this case, the b squared minus 4ac has to be greater than 0. It has to be positive. For part B, there's only 1 x-intercept, so that means that the discriminant equals 0. And for part C, there's no x-intercepts, so that means that the discriminant must be negative. And so those are all your answers for number 7 here. For number 8, we've got the function f is defined by f of x squared plus 4. Which of the following is equal to f of x plus 5? So if f of x equals x squared plus 4, if we want to find f of anything else, like in other words x plus 5, we need to replace every instance of x with x plus 5. And so that's going to be this one right here. Now, none of the answer choices look exactly like this, and that's because they've all been simplified and put into standard form. So what we need to do is we need to square this out, kind of like we did in problem number 1, and then add this 4 to the end. So first I'll square out the x plus 5, and whenever you square something, that means that you're multiplying it by itself. So this would be x plus 5 times x plus 5. Then you want to distribute here. So distributing this means we're going to multiply x by x to get x squared. We're going to multiply x by 5 to get 5x. And then we'll do that again with the 5. So 5 times x will give us another 5x, and then 5 times 5 is going to be 25. So that'll be x squared, remember the x times x, plus 5x, plus 25, and then we have this plus 4 just kind of hanging out at the end here. So the last step is going to be to combine our like terms. 5x plus 5x is 10x. 25 plus 4 is going to be 29, and that's our answer. So we have x squared plus 10x plus 29, and we see that in choice E. Number 9 says, when the quadratic functions below are graphed in the xy plane, is the vertex for each function above the x-axis, below the x-axis, or on the x-axis? And place a check mark on the appropriate box. So this is all about understanding how these different numbers, and they even threw in a negative here, affect the graph. So let's just kind of break down how these different transformations are going to affect our parent function, y equals x squared. So I'm just going to do a rough sketch here. Y equals x squared, or we'll just say f of x equals x squared, forms a parabola. Okay, if each input, or the outputs for each input is that you square that number. So like 0 squared is 0, 1 squared is 1, 2 squared is 4. We get this nice little parabola. Looks something like this. Okay. Now, for each one of these, it's going to transform this graph in a certain way. If I have x squared plus 5, so if I have a, if I'm adding some number to the function here, what that's going to do is cause a shift up or down, and if it's plus, it's going to shift up. So this is going to be a shift up 5 units. And what I'll do here is just kind of break down the transformations, and then we can do a quick sketch and hopefully answer these pretty easily. Now, if you have a plus 5 on the inside of the parentheses here before you square, it's going to have the opposite effect that you might think. Okay, this is going to cause a shift left or right, but it does the opposite of what might be intuitive. So if you have x plus 5, that actually shifts it to the left 5 units. Negative x squared plus 5, this is going to have two transformations. It's going to reflect it across the x-axis because of this negative. So basically, it's just going to flip the parabola and so that it opens downward. But then the plus 5 is going to shift it up 5 units. So we've got two transformations at work here. First, we've got a reflection over the x-axis. That's what that negative sign is going to do. And then that plus 5 is going to do the same thing that it did up here, which is to shift it up 5 units. Finally, this last one, x squared minus 5, that's just going to shift it down 5 units instead of up. Okay, so now that we've kind of broken down how these transformations are going to work, we'll do just some quick sketching to get an idea of what's going to happen. So if this is our parent function, for this one, if it's shifted up 5 units, then basically what's going to happen is you're going to take that parabola and you're going to move it up 5 units. I'm not even going to put any numbers here because the question we're trying to answer here is whether or not the vertex, which is this point right here where the slope changes sign, is above, below, or on the x-axis. And the x-axis is this horizontal axis here. So as you can see, if you shift it up, that's going to bring that vertex above the x-axis. If we were to instead shift the vertex to the left 5 units, then the vertex is going to remain on the x-axis, because if we shift it to the left, it started out on the x-axis. Shifting it to the left is just going to move it over here. And actually, even if you kind of mess this one up in terms of your interpretation, like if you forget that it actually moves to the left instead of the right, even if you forget that, you're still going to get this one right, because even if I shifted this to the right, it would still be on the x-axis. Now, if I have a reflection over the x-axis and a shift up 5 units, what ends up happening is the parabola first gets reflected across the x-axis like this, but then it shifts up 5 units. So that vertex is actually going to be up here, and so the vertex that we're really looking at is right here. So I know this is a rough sketch, but bear with me. And that is going to be above the x-axis. Finally, we've got x squared minus 5. And so x squared minus 5 is going to be a shift down 5 units. So instead of the vertex being at the origin, it's going to be 5 units lower. Parabola is going to look basically something like this. And we can see that the vertex is below the x-axis. And that wraps up number 9. Number 10 says the graph of a quadratic function is shown on the xy plane. First of all, how many real roots does it have? So real roots are represented on the graph as x-intercepts. And so we can see that since this doesn't have any x-intercepts, this should have 0 real roots. The 2 roots will be complex or involve imaginary numbers. Does f of x have a positive or negative leading coefficient? So if it's positive, that means the parabola is going to open up, and if it's negative, it's going to open down. Okay, and so since this one's opening up, we can conclude that it must have a positive leading coefficient. Finally, does the domain or range consist of all real numbers? Well, we can see the domain does because there's no limitation to this going left or right, but the range does not consist of all real numbers because there's no points below whatever this vertex is. So there's no negative y values, there's no 0 y values. We don't know exactly where this is going to end, but we know that the range will not include all real numbers. So we'll just say the domain only. Number 11 says which of the following is not equivalent to this expression. So this is a case, one of those problems where you could just pick a number for x and plug it in and see which one equals the same thing. But I think I'll just go ahead and work it out because this one's not so bad. So basically what I'm going to do is I'm going to put all these in standard form and see which one doesn't match the rest. So first I'll multiply these together. We've done this distributive property a lot on this review, and this is just kind of a common technique for dealing with quadratics, where if we multiply the 2 factors together here, we're going to get 4x times x, which is going to be 4x squared. 4x times negative 2 will be negative 8x. 8x, well, 8 times x is just 8x. And then 8 times 2 is negative 16. When I combine my like terms, which are those 2 linear terms, the 8x minus 8x, these two will just cancel each other out. And so we get 4x squared minus 16. And so anyone that's equal to this is not going to be our answer because we want the one that's not equivalent to it. Now, C obviously is the exact same as here, so we can rule that one out right away. But let's start going through these. So for letter A, I'm going to distribute the 4 and see what happens here. Here I'm going to just multiply 4 by each one of these terms inside the parentheses, and I get 4x squared minus 4 times 8 is going to be 32x, and then plus 4 times 16, which is going to be 64. And here we come across what looks like it's going to be our answer here, because this is not the same as this. So yeah, our answer is going to be A. But let's double check and just make sure that the other two do work out the way we think they're going to work out. So B, I'm going to distribute the 4. Okay, 4 times x squared is just 4x squared. And 4 times negative 4 is negative 16. We can see that this does equal the same thing that we had over here, so our answer is not going to be B. And then just to rule D out finally, we're going to distribute and then follow that up with some combining like terms. So I'll just do that in 2 separate steps here. First, the distributive property, we get 4x times x, which is 4x squared. 4x times negative 2 is going to be negative 8x. And then we have plus 8x minus 16, which looks really familiar to what we have up here. So yeah, we do know that this is going to be 4x squared minus 16. So D can't be right either. And so we've just verified that, sure enough, A is our answer. Number 12 says, write this in factored form. So this is just a matter of really just getting down those factoring skills. So 4y squared, I'm just going to rewrite this in standard form to make it a little bit easier. I am going to use the Xbox method here. But what you could do if you kind of get lost in the factoring is you could just use the distributive property on each one of these, multiply these together and find the one that equals this. So you can sort of work your way backwards on a problem like this. I'm going to do it the conventional way, but know that it might be faster to just multiply these together. But I do want to go over this factoring one more time. Using this Xbox method, it's really helpful to keep your work organized. This is not the only method for factoring quadratics, by the way. It's just the one that I find kind of goes the fastest when you're not sure what the factors are. All right, so we need two numbers that multiply to give me negative 24, right, which is 4 times negative 6, and add up to negative 5, and that's going to give me the two numbers that go in these diagonal boxes. The first box is just going to be the 4y squared. It's going to be that first term. Oops. Okay, I don't know how I ended up doing that, but all right, well, let's just move this back where it was. All right, well, sorry about that. Okay, so yeah, 4y squared, and then we'll put the last term, negative 6, down in this last box. And then, so yeah, to fill in those other two boxes, we need to find two numbers that multiply to give me negative 24, but add up to negative 5. So let's see, I think that'll be negative 8 and 3. Usually these numbers should not be too crazy to come up with. I'm not trying to make this like harder than it needs to be, so don't expect to have like huge factors here. And if they are, if you just like cannot figure it out, you can always use, well, I guess in this case you can't use quadratic formula because it's telling you to factor. But if you're trying to solve an equation, just know you can always fall back on that. So yeah, my two terms here are going to be negative 8x and 3x, and I'm getting those coefficients from playing this little plus multiply game. Oh yeah, we're in terms of y here, not x, so let's fix that. And then somehow my box disappeared. All right, I'm having all kinds of technical issues on this little box method here. Okay, so now we're going to find the GCF out of each row and each column, and those are going to give us our two factors. So the GCF of the first column is going to be 2y. The GCF of the second column is going to be 3. So we'll say plus 3, so it looks a little bit more like what we're going to see in the actual factor. In the first row here, my GCF is just y. And then in the second row, my GCF is negative 2. Oh, wait a minute. Let me look back. This first column, actually 4 and 8, we can go bigger than 2. We can actually take out a 4 there. So that should actually be 4y. Okay, so now that we fixed that up, we've got our two factors, which are going to be 4y plus 3 times y minus 2. And let's hope that we have an answer there, and I do see that it's going to be choice A here. Number 13 says, find the vertex and the roots of this quadratic function. So let's first find the vertex, and that's going to be our negative b over 2a for the x-coordinate. Okay, so the vertex we'll call h comma k. It's that coordinate on the parabola where the slope changes sign. And then the roots is where we'll set the equation equal to 0 and then solve for x. So let's do the vertex first. H is going to be negative b over 2a, which in this case would be 16 divided by 2 times 4. So 16 over 8 would be 2. So the x-coordinate of the vertex is going to be 2. And then to find the k, we're going to plug in 2 back into the equation. So 4 times 2 squared minus 16 times 2 plus 12. This is something you could just put in the calculator here. So let's see, 4 times 4 is going to be 16. 16 times 2 is going to be 32. 16 plus 12 is 28. Again, you don't need to do this by hand. I'm just trying to do it faster so I don't have to pull out the calculator. And so we get negative 4 here. So our vertex is going to be at 2, -4. Okay, so to find the roots, those are going to be the values that make the function equal 0, the x-intercepts or the solutions. So what we need to do is set this equation equal to 0 and then solve it. 4x squared minus 16x plus 12 equals 0. This is one where we can actually make this easier if we divide everything by 4. So 4 divided by 4 is 1, 16 divided by 4 is 4, and 12 divided by 4 is 3. This makes the factoring go way easier. This is going to be our first one that has a leading coefficient of 1. So we actually don't need to use the Xbox method. We can take that shortcut of just finding two numbers that multiply to 3 and add up to -4, and we'll have our two factors. And those two numbers would be, well, -3 and -1. So x minus 3 times x minus 1. And so now we can set each one of these individual factors equal to 0 using the zero product property. And that's going to give us our two roots here. If I add 3 to both sides, I'm going to get x equals 3. And if I add 1 to both sides to this other equation, I get x equals 1. So my two roots are going to be x equals 3 and x equals 1. Number 14 says the height of a ball after t seconds is thrown straight up in the air with initial speed of 64 feet per second with an initial height of 80 feet can be modeled by this function given here. When will the ball first reach 140 feet? So this is kind of like the problem we did back here with throwing up the rock. The rock problem we did, problem number 5, is a little bit more complicated because not only do we just need the first time, but we need the second time, and we need to realize that it's asking for the time in between. For this one, it's just asking for that first time. So we don't have to think beyond that. It's a similar scenario here where the rock goes up and then comes back down. This one starts at a height of 80 feet, geez. So either way, it's going to go up and come back down, where here's 80, okay, and then at some point it's going to hit 140 feet, and we're interested to know when does that happen. So whatever this time is, that's going to be the answer to our equation. So being that this is multiple choice, one way you can get through this problem a little faster is just by plugging in these times and then just seeing which one works. So yeah, but I'm going to go ahead and solve it. Once again, the conventional way. I'm going to set this equal to 140 because we are interested in when it first reaches 140 feet. And then we need to solve this equation. So we'll start by subtracting the 140 from both sides. So 80 minus 140. I think I will actually break out the calculator on this one. It's going to be -60. Now to make this equation work a little nicer, I'm going to try to make all these numbers smaller. And so what I need to do is find something that I can divide all of these by. And they're all divisible by 4, I believe would be the most we could divide out of here. But also, I really don't want this negative sign out front. It's going to be a lot easier to solve this if the leading coefficient's positive. So I'm going to actually divide both sides by -4 just to make this problem go a little easier. So -16 divided by -4 is going to be +4, t squared. And then minus 64 divided by 4 is going to, what is that, 12? No, 16t. And then 60 divided by -4, what the happened to my, I don't know why, like just random stuff disappears here. That's okay. We'll go back and sketch it back in here. Plus 60 divided by 4 is going to be 15. So here, let me try to redraw this real quick. There we go. So now we need to solve this. I think I might just, no, we've done so much factoring here. I think I might just do a little quadratic formula just because it's been a little while since we did one. So negative b plus or minus the square root of b squared. Definitely going to want a calculator here. These numbers are going to get a little big here. Minus 4ac all divided by 2a. Okay, so I'm kind of running out of room here, clearly. But that's okay. I will just simplify this over here. Okay, so 16 is just 16, clearly. And we have negative 16 squared. Gosh, let's get this out of here. Okay, I'll just put it down here for now, but I'll move it back. So I'm going to just put all this stuff right here into the calculator so I get that discriminant. Negative 16 squared minus 4 times 15 is 16, and the square root of 16 is 4. Okay, 2 times 4 is going to be 8. Like I said, the square root of 16 is going to be 4. So I'm going to get two solutions here. One where it's 16 plus 4 divided by 8, and that's going to be 2.5. And then if I do the subtraction, I'll write our final answers down here. 2.5 or, all right, there we go. Then if we have 16 minus 4 divided by 8, that's going to give me 1.5. So there's two times at which this actually hits 140 feet, 1.5 seconds or 2.5 seconds. We can see that it's going to hit that 140 on the way up, but it's also going to hit it on the way down somewhere over here. And so we're interested in the first time that it reaches 140 feet, and that's going to be at 1.5 seconds. So our answer here is C. Now you could have factored this and got the same answers, but again, I just chose to use quadratic formula because I haven't used it in a few problems. We've done a lot of factoring, so I think it's worth the practice. That leaves us with one last problem. The function r of x equals negative x squared plus 135x represents the daily revenue earned from selling graphing calculators at x dollars each. Find and interpret r of 41. So r of 41, first let's just find what it is, and then we'll make a statement on what it means. But r 41 is going to be what we get when we substitute 41 into the equation. Now be careful here. That negative sign is outside of the square, so you don't want to include it inside the square, else you'll get the wrong answer. So we'll type this in exactly how it looks into the calculator. I'm going to go ahead and do that off screen here. Negative 41 squared plus 135 times 41 is giving me 3,854. So that's what it is, where it says find r of 41. This is what it is. But it also says interpret. So we need to interpret what this means. And so just rereading the problem, basically what this means is if the graphing calculators are sold for $41 each, the daily revenue, in other words, how much money the business is making, would be $3,854. So the 41 is how much we're selling the calculators for, and this is the total revenue. And that's going to about wrap it up for this review. As always, please reach out if you have any questions. I'm here and I'm happy to help. But other than that, thanks for watching, and y'all have a great day.